How does the internet really work? There is much information I have seen on TCP/IP protocols/layers, DNS, LANs, VPNs, net schemes, SSL/TLS/etc., and the like, which are, I'd say, more user-facing aspects of the way the internet works. But try as I might, it is hard to learn how the internet really works, its internal parts, etc. Some example questions, to show what I mean by this. When I send a message to a computer over the internet, where, what kinds of places/organizations, and physically where, does the message go through until it reaches its destination? Why do I need to get internet from an ISP? Why can I not just connect straight to the internet? What composes the backbone, the main core of the internet, and how does this work? Is this a secret? Maybe. So, 1. How does the internet really work? What makes it spin? 2. Is it possible to find more good information on these things on the web, and if yes, what are some good resources for this?
The internet is a network of networks. Let's say you have a network of 10 systems, each with an IP address, and Tom had a network, and Alice had a network. You'd need a separate connection to Tom and Alice to talk to either, and the associated cost. Now, let's say Tom is connected to Alice, and you're connected to Tom, and Tom lets you connect to Alice through him. That is peering. Imagine needing to connect to 100 different people separately. You can't have intercontinental point-to-point networks, so you have a series of very high-capacity connections, which are very expensive to maintain. You could, in theory, hook yourself into the main backbone or run your own, but it's cheaper to buy it from a reseller, i.e. an ISP. The ISP also has peering agreements, so you don't have to make agreements separately with Tom, Alice, Ollie, Ivan, Ravi, Vanda. The internet works since it ties together these varied, utterly disconnected networks in a coherent way. Practically each network is an AS, which is a collection of networks. Now that we have gotten an overview, you can trace the route you would take to a server with Tracert in Windows and Traceroute in Linux. Each route would have hops within the ISP, over to a larger ISP, and to your final location. In this case, I'm 4 hops from Singtel's local exchange, XE, 9 hops to Singtel's routers named after beer, 11 hops to their law exchange, Laxo, transferred by Pier 1 in Law through to Pier 1 in New York. Finally, the ISP and hop 25 can pass our traffic to Stack Overflow servers. Our traffic with Stack Overflow, in this instance, travels through 25 connected networks until it arrives at Stack Overflow servers. Singtel is an AS for our purposes, as is Pier 1. These routes are decided by BGP between networks, so that I would connect from Singtel to Pier 1 LA, and ERP within an AS. Hypothetically, you could run your own AS, make your own peering agreements and so on, but it would be very costly.
Here's a very high-level view. The internet is basically a worldwide group of networked computers. To facilitate the huge amount of traffic transported across these networks, governments and private companies lay massive cables between countries. These major cables are the backbone of the internet. Occasionally a ship will drag an anchor over one of these and damage or possibly even break it. If this happens, it can cause a major outage for a particular country. To get connected to this backbone, you need to pay fees to the owner of the cable, and you need the hardware. These are major costs, on the order of hundreds of thousands, if not millions of dollars. If you personally had the money, you could connect without an ISP. Most people find it more cost efficient to pay a small monthly fee though. Whenever you send information across the internet, the information has a destination, a URL for example. Network equipment finds it very hard to direct a message, split into packets, to a text address, so network equipment called routers store internal lists of URLs matched with numbered addresses, an IP address, e.g., 203.35.57.110. This is called DNS, Domain Name System. There are various tiers of DNS servers. If a DNS server cannot find an IP in its own DNS, it asks its parent. These addresses are usually split into ranges across countries, i.e. 203.xxx is Australia. Not all networks know every single IP address. They only know a very small list of addresses, enough to direct any packet that comes their way. Example, you want to open the superuser home page. You type superuser.com into your browser and hit enter. Your computer looks at its internal DNS for superuser.com and converts it to an IP. If it doesn't find it in its DNS, it asks your ISP's DNS and so on up the chain until it gets an IP, 64.34.119.12. Your computer asks your ISP's router to send request packets to 64.34.119.12. Your ISP's router looks at its routing tables to see where it should send your request. It sees that 64.x.x.x is outside of its local network and therefore it cannot send it directly, so it sends the request to a higher level router. This goes on and on until the packet hits a router that knows that this IP is somewhere in the US, so it then sends the packet to the closest router to the US that it knows about. The US router sees that the next number in the IP is 34, and if knows that this is on the East Coast somewhere, so it sends it in that direction. Somewhere down the line a router sees that the IP is allocated to a particular ISP, so it sends it to that ISP. The router at the ISP sees that the IP is one of its own and knows exactly which machine to send it to. The receiving machine gets the request and sees that you have requested the home page, so it gets the data together and sends it back to you. The process starts all over again. This all happens in a matter of milliseconds. This is just a simplified general overview. The IPS can be allocated in different ways. A very large company or military organization might own all of 125.xxx.xxx.xxx, yet a small country may only be allocated 275.24.xxx.xxx.